All righty, here we go. Lesson 4. Let's dive in. Actually, before we dive in, I do have one little thing you need to do. This lesson requires an additional printout. In activity number 2, you're supposed to take a bunch of cards and put them in order. So you need to print out, if at all possible, print out those cards. Okay? So on the link for today's lesson, there is also a link right below that to the paper I'm talking about. Print out that paper. It's called a black line master, I think is what they call it. Make sure you print that out. You're going to cut on the lines and cut out all those cards. And then when we get to activity number 2, those are the cards that it's talking about that you'll be putting in order. Okay? Now, we'll talk more about that when we get there, but make sure before you start this video that you have those ready to go. So pause it right now real quick. Go and print that, cut those out, and have them ready to go when we get to that, okay? All right, you should be pausing this right now if you need to do that. Okay, let's move on. Here we go, lesson number 4, activity 1. How do they compare? Before we begin, once again, we need to understand these symbols because we need to use those symbols to compare each of these numbers. So once again, on our notes, we're gonna write, that is the greater than symbol. This one is the less than symbol. And I hope we all know that that is the equal to symbol, right? So I'm not even going to write that one down. Make sure we're memorizing those. Here we go. 12 and 19. 12 is less than 19. 6.050 and 6.05. Oh, look how close those are. Does it matter that that has a 0 at the end? Absolutely not. Those are equal to each other. Very good. 212 and 190. 212 is greater than 190. 0.4 or 4/10, I'm going to rewrite that as a fraction because this one's a fraction, is 4/10 less than, greater than, or equal to 9/40. Well, let's put these into the same denominator. I would have to multiply this by 4, so I would have to multiply that by 4. That would give me 16/40. Is 16/40 greater or less than 9/40? Well, it is greater than. Okay? Next, 15. Less than, greater than, or equal to 1.5. That's definitely greater than. 19/24 and 19/21. Okay, so the numerators are the same this time, but the denominators are different. But that's okay. We don't have to make them the same if we think about what this means. If I have 19 of something that is 24, like of a whole, let's say it's a pizza. And if we have a pizza that's cut into 24 pieces, and I ate 19 of them, is that more or less than a pizza that was cut into 21 pieces and I ate 19 of them? Well, these are bigger pieces, right? Because there's fewer of them, so that means these are bigger pieces. If I ate 19 bigger pieces, that's the bigger number, so that has to be a less than symbol. 19/24 is less than 19/21. That one was tricky. Let's move on. 9.02, so 9 2/100 compared to 9 2/10. Well, if we compare the tenths place, the ones place is the same. Tenths place, 0 compared to 2. Well, that 2 is bigger, which means that 0 is less than. So 9.02 is less than 9.2. Last one, 16/17 and 11/12. This one's actually quite similar to this one over here. We have to think about wholes here. 17/17 is one whole, so that's really close to one whole. Same thing here, 12/12 is a one whole, so that's really close. So we have to compare the size of the pieces. If a pizza is cut into 17 pieces, those are smaller pieces than if it's only cut into 12 pieces, right? Because I have to cut way more pieces here. So this piece that's left over is really small compared to this piece, which means that is less than. Oh, well, I just misspoke. I hope you are all yelling at me. If that's the smaller piece, that means it's closer to 17, which means that's greater than. My bad on that one. That was close. Okay, how many of you got all of those right? Let's see, there were 2, 4, 6, 8 of them. So 6 out of 8 will be mastery. Give me a big woo woo if you got 6 out of 8 or better. Woo woo! Very good, very good. Now, activity 2 time. This is the one I was talking about. I hope you cut out your cards. I hope they're all ready to go. Pretend that I handed those to you. I didn't really, but pretend I did. And now you have your cards. You're going to put those in order from least to greatest. Now, there's a whole lot of cards. There's like 40 cards. Now, there's actually 2 sets there. You'll see on that paper, there's kind of a line dividing set 1 from set 2. Don't worry about doing them separate. Just mix them all up and put them all in order. Make sure that all 40 cards get put into order. I would like you to have a parent or an older sibling or somebody older than you that knows what they're doing. Check that for you, okay? So that you are sure that you got them all in order. And make sure you have good discussions with those people so that you know that they know what they're talking about. Second thing I would like you to do, I want to do a little competition with this one. I'm going to say, I want you to take a picture. When you get these all laid out, I would love it if you'd grab somebody's cell phone, take a picture of your set all laid out and email that to me, okay? If you email me your set of cards and you are one of the first, let's say 20 people that email me your cards, I'll give you a bonus prize like we talked about the other day. Bonus prize can be a free homework pass. It can be for giving one of those check your understanding quizzes. It can be bonus points on something. So whatever you want it to be, well, not whatever you want it to be, whatever I want it to be, it will be some kind of a bonus prize for being one of the first 20 kids to send me an email that includes a picture of those cards. So that's a fun little activity. Pause this video and go do that right now. Put all 40 of those cards in order. Ready, set, go. All right, we're going to pretend like we're done pausing. We've all put those in order. You've sent me the pictures, right? And now we're going to move on to activity number 3. Comparing points on a line. Use each of the following terms at least once to describe or compare the values of points M, N, P, and R. Okay, so let's come up with a statement that uses the phrase greater than. Well, anything to the right of something else will be greater than. So one example of something we could say with greater than is that P is greater than, well, it doesn't even matter. We can pick between these two because P is to the right of both of those. Let's say then N. P is greater than N. Less than, well, less than has to be on the left. So let's do point M. M is less than N. Why not? Or P or R, because those are all to the right of it. So it doesn't matter which one we pick. M is less than, let's say, N. Opposite of. Okay, now remember from a couple of days ago what opposites mean. Opposite means the same distance from 0, like -2 and +2, -5 and +5. So we need to know their actual values in order to compare those, okay? So let's find the values of these. M, let's count. 1, 2, 3, 4, 5, but it's in the left-hand direction, so that's a -5. N is -1, -2. P is on the positive side of things, and it's 1, 2, 3, 4, 5. And R is 1, 2, 3, 4, 5, 6, 7, 8. So did you find the pair of opposites? M and P are opposites, -5 and 5. So M and P are opposites. Or you could have said the opposite of M is P, or the opposite of P is M, or something. You could have worded that however you wanted. A negative number. Well, one of the good things about doing the values is that we already know which one's a negative number now. Both M and N are negative numbers, so it doesn't matter which one you pick. I'll just say M is a negative number. Good. Now I've got a phrase that describes each and every one of those. Done with number 1. Moving on to number 2. Tell what the value of each would be if, we're going to need this number line again. If P is 2.5. Okay, so we kind of have to ignore, we did this assuming that these tick marks were whole numbers, and they're not necessarily whole numbers, right? So, what if P is 2.5? I'm going to label that. If that's the case, what would the value of M, N, and R be? Well, we got to figure those out. M, N, and R. We got to figure out what our tick marks are. Let's see, there's 1, 2, 3, 4, 5 tick marks here. I'm wondering if they're halves. If I go 1/2, 1 whole, 1 1/2, 2 wholes, 2.5, that makes sense. So 1/2, 1, 1 1/2, 2, 2.5, 3, 3.5, 4. There's R. R would be 4. See how I'm doing this? I hope you can see what I'm doing here. I think you can. Now, what would N be? Well, now we have to go backwards. Same increments here. -1/2, -1. There's N. N would be -1. -1, whoops, 1 1/2. -2. -2, whoops, and 1/2. My goodness. -2 and 1/2. See how I counted by halves? 1/2, 1, 1 1/2, 2, 2.5, but in the negative direction. So M is -2 and 1/2. Okay? Notice M and P are still opposites. Even though we changed their value, M and P are still opposites. Pretty dang awesome. All right. Now we're going to use that same number line once again, but this time I'm going to have to erase these again because this time we have a different value. All right, here we go. This time N is -0.4. So let's label that. -0.4 or -4/10. Well, if that's the case, we got to figure out what M, P, and R would be. So M, P, and R. Okay? So if N is -0.4, we got to figure out what all these increments are. Well, halfway between 0 and -0.4 would be -0.2. So I think we're counting by 0.2s. 0.2, 0.4, 0.6, 0.8. That would be 1 whole, right? And 1.2. But these are all negative, right? They're on the negative side of things. So there's our M. M is at -1. So let's transfer that over here. M is at -1. Now we got to go all the way to P. Okay? So if we're counting by 0.2s, this is 0.2, 0.4, 0.6, 0.8, 1. Well, look at that. M and P are still opposites, -1 and 1. It totally makes sense. So P is 1. I could have even done that before doing it on the number line because I knew those were opposites, right? Now for R, I'm going to keep counting. 1, 1.2, 1.4, 1.6. So R is 1.6. There we go. Moving on. Once again, I'm going to have to erase my number line. That's okay, though. This is good practice. All right, here we go. Now R is 200. So let's label R 200. Okay. If R is 200, we got to figure out what our increments are. We have 1, 2, 3, 4, 5, 6, 7, 8. So 200 divided by 8. 200 divided by 8. Well, 8 goes into 20 twice, which is 16. 8 goes into 40 5 times. So I think they're counting by 25s. Let's try it. 25, 50, 75, 100, 125, 150, 175, 200. Look at that. Not only did we verify that, yes, we are counting by 25s, but we just found P in the process, didn't we? So let's write that down. P is 125. We're also needing N and M. Okay, let's go backwards now. If we're counting by 25s, then I've got to go backwards. Negative 25, negative 50, negative 75, negative 80, and 80, gosh. Negative 100, negative 125. So 25, 50, 75, 100, 125. I'm right. M is negative 125. Again, M and P are opposite, so there's my double check. And along the way, I found N, and I just didn't even realize negative 50 is N. So I can fill that one in as well. There we go, last one. Once again, we got to erase our number line. My poor eraser is getting down to nothing. How about yours? That's okay, though. If we need to supply more erasers, we can, I guess, huh? All right. My 0 keeps getting erased. All right, let's do this last one. M is now negative 15. So let's figure out what the rest of these would be. We'll need N, P, and R. Okay. We have 1, 2, 3, 4, 5 increments to fill. 15 divided by 5 is 3s, so I think we're counting by 3s. Negative 3, negative 6, negative 9, negative 12, negative 15. I was right. So now I know that N is at negative 6. Now, pop quiz. What is P going to be if M is negative 15? We know M and P are opposites, so what's P going to be? Positive 15. Let's double check. 3, 6, 9, 12, 15. We were right. Let's keep counting. 18, 21, 24 is R. 24. Done. Look at that. We just finished our lesson number 4. Again, optional. If you want to try this one, it's a good one. The only thing left is the lesson summary, which is a real short one. There is a graph on there too. Real short lesson summary. There's no new vocabulary words today, so we don't need to worry about that. Hopefully, we are a little bit better at greater than and less than, plotting numbers on number lines and talking about them, as well as finding all these different ways of labeling number lines. What a great activity that was. I really liked that one. If you have any questions, though, make sure you're emailing me. I would be more than happy to help you out with that. You know what's next. Practice problems. Dive into those. Do your very, very best to answer each and every single one of those. I want to see how many of you can get a 100%er on your own before watching the rest of the video. If you do, I want to hear about it. Email me. Tell me, Miss Hatch, I got 100% on that homework even before I watched your video. You let me know because I want to celebrate that victory with you. Please let me know. Email me. Let me know when you get 100% on homework, or even if you just did awesome. Maybe you only got 4 out of 5, but that is still awesome. Let me know how you did, okay? Now, go ahead and jump into that homework. And as always, don't ever forget, you know what's coming.
Do your best, because you deserve your best.
Lesson 4 homework time. We made it to lesson 4. Here we go. I hope you did your homework on your own and now you are ready to grade it on your own. And let's see how many of you got 100%er on this one. I'm excited to find out. Select all of the numbers that are greater than -5. Ooh, negative. Okay, greater than a negative. Every single positive number is going to be greater than a negative number, right? So let's start there. Which ones are positive? They have to be greater than -5. 1.3, that is positive, so that's going to be greater. Well, we'll come back to that one. We'll come back to that one. But look at that, positive, so that has to be greater. We'll come back to that. We'll come back to that. Okay, we took care of 2 of them. Positive numbers are always greater than negative numbers, so we've checked those. They're done. Now, the next thing we need to look at is how do each of these negative numbers compare to -5. And to do that, I'm actually going to draw a number line. I think it really is handy to have a number line go in here. And these are all going to be negative. So I'm going to put my 0 over on this side. -1, -2, -3, -4, -5, -6, -7. Okay, so now I've got my number line drawn. This will help me figure out -5 lives right here. So I'm going to make sure that's what I'm comparing all these numbers to. So is -6 greater than -5? It's to the left, so it is not. See that? See how much a number line helps? -12. Well, -12 isn't even on my number line. It's clear over here. So can that be greater than -5? Absolutely not. That is way too small. So that one's out as well. How about -1? -1's right here. That is to the right of -5. So that is also a yes. Very good. Last one, -4. Ooh, it's close, but it is still to the right. So that is also a yes. Look at that. 1, 2, 3, 4 correct answers on that one. Did you get them all? Hope so. Good work. Next, order these numbers from least to greatest. Oh, I like this kind of problem. Let's start with the lowest. We know negative numbers are less than whole numbers. So let's focus on our negatives. Here's one negative, another negative, and another negative. Which one of those is the furthest to the left? Well, my dog, I swear, why does my dog hate it when people walk by? Or actually, this may be some kind of a dog or a cat or something in the front yard. I don't know what he's doing, but it's driving me nuts. I apologize about the dog barking in the background. So, -1.5, -1/2, and -1. Which one of those is farther to the left? Well, we can use this number line to kind of help us. -1.5 would live at -1 and 1/2. So there's where that would live. -1 and 1/2. -1/2 is only halfway, so it's here. And -1 is right here, right? So let's put those in order. From left to right will be least to greatest, right? So -1 and 1/2 comes first, and then -1, and then -1/2. See how I did that? I'm going to move that comma down a little bit so you can see it. So we took care of the negatives. Done, done, and done. Now we just have the positives left over. Well, we know that 0 is the smallest, not really positive number, but the smallest of those. So 0 is next. And then we have to decide between 1/2 and 1. Well, we know fractions are less than wholes. So that has to be next. 1/2 is next. And then, of course, 1. So there it is. There's our answer for number 2. Okay? Number 3. Here are the boiling points of certain elements in degrees Celsius. List the elements from least to greatest boiling points. All right, here we go again. Least to greatest. So we're looking for the biggest negative number. I notice that all of these are negative. So which one's the biggest negative number? Hydrogen. So hydrogen comes first. We're listing the elements, by the way, not the actual numbers. We're listing the elements. So hydrogen is first. It's the biggest negative number. What's the next biggest negative number? 188 is bigger than 185. So I think fluorine is next. Fluorine is next. Now, that was a close call, but I think that one now, argon, is next at -185. Now I've got 153 and 34. Well, that's no competition. 153 is way bigger than 34. So this one, krypton, is next, leaving chlorine to be the biggest of these very small boiling points. Very good. Done with number 3. Number 4, explain why 0 is considered its own opposite. Oh, remember when we talked about that a couple of days ago? 0 is the only one that is its own opposite. And the reason why is because 0 is the same distance, whoops, I can spell, distance from 0 as is 0. And I know that sounds really crazy, but that's really the best way to explain it. Remember, opposites are the same distance from 0. 5 and -5 are both 5 units from 0. 3 and -3 are both 3 units from 0. Well, 0 is its own opposite because it is 0 units away from 0. It is the same units away from 0. It just happens to be a distance of 0. So I know that's kind of a weird way of wording it, but that's the best way I have found to explain that. Okay? I hope that wasn't too low. That might have been too low. But you heard me. 0 is the same distance from 0 as is 0. Yeah, kind of a funny way to word that, but it works. Explain how to make these calculations mentally. I'm sure it's talking about whatever is on the next page, so let's flip that over. Explain how to make these calculations mentally. Ah, here we go. Yes. Well, there's some great strategies we've talked about in the past to making math problems really easy. Whenever I see a number like 99, I automatically round it to 100. 100 plus 54. Okay, I'm going to add, remember we're explaining, add 154, right? And that would equal 154. But we really don't have 100. We have 99. And 99 is one fewer. So now we have to subtract 1, which would give us 153 as our final answer. Okay, so 99 plus 54 is 153. I added 100 plus 54, but then I knew I had to subtract the 1 that I added in there. Okay. Another one. Here's another 99. So let's turn that into 100. Let's subtract 100 from 244. Well, that's easy math. 244 minus 100 is 344. But I don't need to subtract all 100. I only had to subtract 99. So now add 1 back in. The answer is 345 is my final answer. Okay? Here we go. 99 again, that's 100. So I'm going to multiply, that's a P, by the way, multiply 100 by 6, and that would be 600. But there are 6 here that too many, right? Because it's actually 1 times 6, 6 times. So now I have to subtract, subtract 6, right? So the answer is not 600, but 600 minus 6, which is 594. Okay? Last one, 99 times 15, very similar to this one. We're going to do 100, multiply 100 by 15. That's 1,500 or 1,500. But now I have to subtract how many? Well, it was 1 too many 15 times, right? So I have to subtract 15. So 1,500 minus 15, and I might have to do some borrowing here. So that's 5, 8, 4, 1. 1,485 is the final answer for part D. Okay. Okay? Very, very good. Number 6. Review from Unit 4. That was a while ago, but we can do this. Here we go. 1/2 divided by 2. Well, we're dividing fractions here. Even whole numbers are really fractions, right? So I'm going to pretend that that's a fraction. And I'm dividing by a fraction. So I know when I divide by a fraction, I have to flip and multiply. So what we actually have is 1/2 times 1/2. We flipped it. And that equals 1/4. So there's our answer. Okay? Oh, can't get any easier than 2 divided by 2. We already know that's 1. Oh my goodness, 1/2 divided by 1/2. Do I even need to do the math here? No, because they're the same. So that equals 1 as well. Sweet. Oh my goodness gracious. 38/79 divided by 38/79. Do I even have to think about that? No, because again, they're the same number. So that's just 1. Holy cow. Fast and easy. Last one, number 7. Over several months, the weight of a baby measured in pounds doubles. Does its weight measured in kilograms also double? Well, let's just compare. I know that 1 pound, 1 pound equals approximately 2.2 kilograms. I just happen to know that because, I'm a math teacher. I know these things. Okay. So let's say that I have a 10-pound baby, couple weeks old, weighs 10 pounds. That means that they would weigh, 10 times 2.2. Whoops. My time sign got too close. So that's 0, 2, 0, 0, 2. So 220, right? 220 kilograms, right? So if a 10-pound baby weighs 220 kilograms and I double the pounds this baby, so now he weighs 20 pounds, would that also double my kilograms number? Does the weight in the kilograms also double? Well, let's try it. What is 20 pounds times 2.2? 20 times 2.2. See how I did that? Because I know 1 pound equals 2.2. So 20 pounds times 2.2 should give us our weight in kilograms. Does that make sense? So 2 times 0 is 0. 2 times 2 is 4. Placeholder. 2 times 0 is 0. 2 times 2 is 4. So 440. Look at that. What is 220 times 2? 440. Yes. Yes, yes, yes. If you double the pounds, you're going to double the kilograms. Yes, it does. Now, my explain is kind of in this work, but it shows it, right? So, example, a 10-pound baby doubled equals 20 pounds, which would equal a 220 kilogram baby doubled equals 440 kilograms, right? So both things doubled. 10 times 2 is 20. 220 times 2 is 400. All right, so our good explanation is there now. We are done with lesson 4. Congratulations, ladies and gentlemen. If you didn't already look ahead to tomorrow's lesson, there is no lesson tomorrow. On Fridays, we're going to have catch-up days. So this is the last lesson of the week, guys. You just finished week 3's homework. Well done. Now, there is one last thing you need to do, and that is the Check Your Understanding quiz. Don't forget, go back to Canvas and do that short little quiz just to show me how well you know how to order rational numbers. Make sure you do that. Celebrate with me on your scores. Don't forget to pat yourself on the back for a good week. Well done. If you're not quite done with everything this week, make sure you go back and finish that. We want to start fresh, ready for lesson 5 on Monday. So don't forget to finish everything from this week. Tomorrow you have an extra day. I'm not going to do another lesson tomorrow, so you have extra time. Go back and finish anything you haven't finished. You guys have done so great this week. It's so great. I literally picture you in my mind as I'm doing these videos, and it's super fun to think about you. So make sure you're working hard. Ask any questions you have via email. Make sure you're emailing me any questions you have, and I will for sure answer those. Good job. We'll talk to you later. Bye.